Okay, friends, make sure you take out your notes right now. I'm going to need you to write some things down. We're going to go over the homework that you had to turn in last night. Please do not open up your homework or unsubmit it. Please keep it submitted. I will project the key and I will talk you through some of the things that I need you guys to be able to brush up on. Thumbs? Good? Okay, thank you. Everyone's camera should be on as well, please. Thank you. All right, so let's take a look here. We've got the Superbug homework. This is an example of how MRSA can spread through your skin and tissue. That's pretty nasty. Your table was given to you with information already inputted, right? So anything that was in blue on your data table was given by me. And then your job was to go ahead and fill in the rest of the table. There was some questions as to why I had all the zeros on here and stuff like that. Again, at the beginning, you always start with time 0, number of divisions 0, and 1 bacterium. So at the very beginning, you're always going to start with 1. And it hasn't divided yet, so you have to put a 0 for divisions, right? Then in the rest of the column, you could just go ahead and input the rest of your divisions. Again, here we had 1 through 7 in our table. Once you have that, you can go ahead and use the formula. And of course, who can tell me what the formula is to calculate the number of bacteria? Victor, what is it, buddy?
It's 2 to the n power.
Yeah, where n is equal to, this is the important part, the number of what, gang?
Divisions.
Yes, right? 2 to the n, where n is equal to the number of divisions. Make sure that you remember that. If you use any other value, your number is going to be wrong, okay? Your total answer is going to be off. So once you go ahead and put those numbers in, then you'll be able to see, right, and compare your answers to the ones that I calculated over those 7 divisions. And then finally, the last part of your column that you have to fill in is what is the rate of division, right? So the information that was given to you said that this bacterium divides once every 12 minutes. And so you had to go by 12s all the way down. I happen to put where the 1 hour mark is and where the 2 hour mark is to make it easier on me if I needed to go back and look and see, oh, okay, now I know exactly how long this has taken me. We don't think about time in minutes. A lot of times we think of time in hours. So again, that's just something that you could do. I didn't ask you to do that, but it would be helpful for you if you did that, right? So now we go ahead and we open up a Google Sheet and create our graph. Raise your hand if your graph looked like this. Okay, very good. And so this graph was made based on the data that you inputted. So if your numbers were wrong up here, then you're going to have something that looks a little bit different than this, right? There were a couple of people who did some crazy calculations here and got things wrong. Again, it's not going to be a huge issue. Yeah, you'll get some points off, but it's not going to be that big of a deal. The overall picture here should look like this, though. Once you've got that done, you start answering the analysis questions. Let's take a quick look at that. What type of growth curve do you see on your graph and why? I write here, the graph shows more of a sigmoid curve, like an S curve, since the number of bacteria do not divide indefinitely. Near the 84-minute mark, the number of bacteria plateaus or levels off. 84-minute mark is right around here. We look in here, we can see this is where we start to plateau, yeah? Right around the 84-minute mark. We see that in our image, our graph. And this is because there must be some sort of limiting factor or factors. Could they be environmental conditions? Could it be a rapid immune response? Your body's trying to fight this infection off. You don't typically recognize an infection right away, but your body does. And for something with MRSA, MRSA can actually work pretty quickly. So we have to be careful with that. This is why, you know, at high schools and grade schools, we have to clean down all of the mats for cheerleading. We have to clean down all the mats for wrestling, right? The custodians have to come in every day, and they should be using a bleach solution in the locker rooms. And so this is why, so that we don't pass on these highly contagious bacterial infections. So if we had constraints or limits to growth to be placed on the MRSA bacteria, like the addition of antibiotics or heightened immune response, what would you expect the graph to look like and why? If there were constraints, I would expect the graph to have a sigmoid curve to indicate slowed growth and possibly death. I would definitely not expect to see a J curve, right? What's the difference between an S curve and a J curve? What does the J curve do?
A J curve, it goes on forever exponentially.
Very good. So J curve represents exponential growth, and we will not see a change, right? This is considered like ideal conditions for the bacteria because there's no constraints on it. But is this real? No, this is not real, right? Real life always puts constraints on systems, right? So in this case, your immune system, your body is a system, bacteria, viruses, no matter what the pathogen is, it's never going to have free reign to just take over. And so remember K. What's K?
Carrying capacity.
Very good. Carrying capacity. Sorry, I typed the V real fast. Must have hit that before I hit C. So there are limits to growth, right? Closer you get to the carrying capacity, the closer you're going to start showing that plateau. And then finally, you guys were asked to sketch what the 4 phases of exponential growth and decay look like. And so your sketches should have looked something similar to this. Again, this is something that I did in the drawing command, right? So I just used straight lines for the Y and X axis. I ended up using a curved connector. So you do that by, if you have a curved connector, whoop. How did I do curve? I can't remember. Yeah, maybe I did this. You just keep clicking, right? So again, in this situation, it was easy for me to put this kind of sigmoid, this S curve, and then at that little tail, add that on for the death phase. So again, pretty easy to do that kind of a sketch. Some people chose to do it with a freehand, and that's okay too. I can't remember who it was. I think maybe it was Barada. Johnny, did you do it with a freehand? I can't remember.
Yeah.
Yeah, there were, which is fine. I recognized what it looked like. It made sense to me. I want to say there was somebody in second period. It just looked bootleg. I still recognized it. I understood, but you know, there's easier ways to sketch things. Hence, what I'm showing you here, right? So, if you need help with this kind of stuff, don't be afraid to ask, right? I think a lot of people did a nice job, so I appreciate that. Anybody have any questions? Follow-up questions? No? Okay. All right, gang. Do you guys like Bill Nye? I hate Bill Nye. Enjoy this video. There's a reason why I hate Bill Nye, and the reason is in this video, he does something that shows that he is no Mr. Lazzarato. If you can pick up on that, I'm not kidding, pick up on what he does wrong in this video, and I will give you a standing ovation. All right. So watch the video, see if you can figure out what he does wrong, and they'll know why I hate his guts. All right. Hold on. Let me mute my.
Mr. Laws, are you showing the video?
Is the video not showing? It is showing? Son of a. Okay. This is all Bill Nye's fault. This is, okay, that was the first reason why I hate his guts. In the video, do you guys see it now? Okay, here it is. It's presenting now. Okay. Excellent.
World War I. More than 10 million dead, many from the infection of their wounds. After the war, research intensified to find safe methods of repelling the bacterial invaders. Among those on the case was Scottish physician Alexander Fleming. While studying Staphylococcus bacteria, Fleming noticed something unusual growing in the culture dish, a mold, Penicillium notatum. He saw that the bacteria surrounding the mold had died off, which led him to speculate the mold was producing a substance that was lethal to the bacteria. He named the substance penicillin. For the next several years, Fleming tried extracting penicillin and applying it to treat infections. But he was unsuccessful and eventually gave up. Fleming's work, however, proved invaluable. In 1935, scientists Howard Florey and Ernst Chain at Oxford University came across a record of Fleming's curious but incomplete work with penicillin and decided to investigate. This time they successfully extracted and purified penicillin. And in 1940, they tested it. They injected 8 mice with lethal doses of the bacteria Streptococci. Then they injected 4 of the mice with penicillin. Within hours, they beheld the results. The 4 mice not treated with penicillin were dead, but 3 of the 4 that had been given penicillin were alive. From Fleming to Florey and Chain, the world's first antibiotic was born.
It was a miracle drug. It cured so many diseases that had caused so much pain and suffering. Strep throat, rheumatic fever, scarlet fever, syphilis, and gonorrhea. It was things that we wouldn't even think about today should kill you.
Well, did you figure it out?
Was it that he pronounced certain things slightly differently than you do?
Slightly differently. How about incorrectly? Lagunas, what did he mispronounce?
Staphylococci, and I can't remember the first one.
Is that how it's pronounced? Staphylococci? Are you serious? This is Bill Nye. How do you say it? How is it supposed to be pronounced? It's not caca. The famous footballer. So you guys don't know how to pronounce it either? Staphylococci? Oh, you guys are communists too. And Lagunas is wearing a Leiden sweatshirt. Does she even know where she's going to high school right now? Seriously. This class, it's just getting worse throughout the day. Second mod, they were sleepwalking. Nobody answers in second mod. I get to third mod. I get people who don't even show up in Elmwood Parkware. Colton has to have his name on his room just to remember it. Look at that. Oh yeah, that's my room. I forgot. It says Colton on the wall. Johnny had to look behind him and see if he was in his room. Are you in the garage, Johnny? Why are you in like a tube? What is that?
That's the rest of my room. I'm in like a nook.
A nook.
The window's in front of me. This is like I don't know.
This is like a cubicle in your room. I like it. Looks good. Yeah. You guys are communists. That's all there is to it. All right. What year? In what year did Florey, Chain, and Fleming receive the Nobel Prize?
1941.
Who was that? Was that Rose Petal?
Yes.
Rosie, that was not the correct year.
Was it close?
Nice. What was it close?
1945.
Yes. Andrew and Andrew and Johnny got it right. Yes, Rose, you were in the correct century. Very good. Very good. Just random. 1871? Was I close? All right. Keep doing drugs, Rose. That's good. All right. Excellent. Excellent. No, you were very close. 1941, right around World War II. That's when penicillin was used on humans. Oh my God, I can't spell human. So make sure that should be in your note as well, gang. All right. All right, we're going to shift gears. We're going into viruses right now. Viruses. Marta, are you there? So if you take a look at these pictures on the screen, you see a wide arrangement of different shapes of viruses. Please write this down. Viruses are 100 times smaller than bacteria. 100 times smaller than bacteria. And another major misconception is that people think that viruses are alive. Viruses are not alive. In fact, viruses don't follow the 8 properties of life. Well, the one that they do follow is respond and adapt and evolve. Other than that, they're not made up of cells. They can't reproduce, right? They replicate. They make a copy of themselves in the host cell. They literally take over the host cell. They don't need energy to live. So we call them, or I call them, nucleic acid machines. They're not living things. They're not organisms. If we take a closer look at viruses, you can see they're only made up of proteins and one of the amino acids. They're either DNA viruses or RNA viruses with a protein coat called a capsid. When you get a viral infection, it progresses in one of 2 ways. It's either a temperate infection, where you get infected and it sits around and you're asymptomatic and you don't even know you have it until one moment down the line it explodes in your tissues and replicates all over the place, killing cells, versus a virulent type, which starts replicating right away, starts destroying cells right away. And we'll talk about the differences and similarities between those 2 types of infections, a temperate infection or a virulent infection. And if you've been paying attention the last couple of days throughout this unit, I've been mentioning that, antibiotics kill that's going to kill a virus. Once you get infected, you have that infection forever. Colton, are you writing this stuff down? Yeah, please do. Homeboy literally is sitting on his hands. I can see that he's not writing. Now he's writing. There it is. There it is. There's a pen. Love it. So you guys have had viruses in the form of the flu. You've had them in the form of the cold virus. And so those strains, that particular type of cold or that particular type of flu is in your body right now. Your immune system acts as like a library. So your immune system acts as a library to remember each infection by its surface. So every pathogen has a certain surface set of proteins that help your immune system recognize it. And if it's a new virus to your body, then your immune system is not going to work right away because it doesn't recognize it. There, you don't have antibodies to attack the new foreign invader. By the time your immune system recognizes that it's a bad thing in your body, it's too late sometimes. It depends on your level of immune system. If you have a weak immune system, then it could be fatal. And that's what we've seen with coronavirus. Some individuals have a weakened immune system. They're immunocompromised. That's the term. Because of age or because of some pre-existing condition, right? Like because coronavirus is a respiratory virus, if people have COPD or and that's chronic obstructive pulmonary disorder, so their lungs are not working correctly, that can affect them significantly, right? And so people with pre-existing lung or respiratory conditions suffer greatly when it comes to COVID. So viruses come in two basic forms. There's the enveloped virus that has like this extra coating on the outside, and then there's the non-enveloped virus, which just has the protein capsid and the nucleic acid core. Notice that both versions have a capsid and a nucleic acid core. It's just the enveloped virus has a lipid membrane on the outside. And so this kind of flies in the face of the idea that there's only two parts to viruses. Because remember, initially I had said that there's only two parts. There's the protein capsid and nucleic acid core. But there are some variations of viruses that are enveloped. Now, thankfully, if you have an enveloped virus variant, those are easier to kill. So when you're disinfecting your surface, like in your kitchen or in the classroom here, right? We have to wipe down our desks now. Any viruses that are left behind, you sneeze or you cough and you leave this, phlegm or expectorate onto the surface of the table, we can wipe it down to kill the non-enveloped viruses. Now, the enveloped viruses are easier to disinfect for. In fact, I have a goggle cabinet. All the science teachers have goggle cabinets that has a germicidal light bulb. And so by turning on this wavelength of light in a closed cabinet, it kills the viruses and bacteria with this particular wavelength of energy, breaking down their membranes and breaking down any sort of capsid that might be harmful. When you guys get back in the classroom, I'll show you how it works. I usually have 1 or 2 people every once in a while. They are the goggle gatekeepers. So they make sure everybody puts their goggles back correctly, and then they literally turn on the cabinet to kill all the germs in the cabinet. Now, there's 4 shapes that we're going to talk about very quickly, and we're going to call it a day. These 4 shapes are for viruses. How many shapes did bacteria have, gang? Basic shapes? 3. Very good. 3. So 3 basic shapes for bacteria, 4 basic shapes for viruses. The first one is called polyhedral. Polyhedral. And as you can see, we've got a protein capsid and the nucleic acid core. This is an electron micrograph of mastodinovirus, which is very similar to the flu. In fact, I want to say that a couple of years ago, there was a mastodinovirus outbreak on a cruise ship. I'll have to look that up. But people were getting sick on the cruise ship, and it spread like wildfire because nobody could leave the ship when it was out to sea. And so when you're in close quarters like that and you have an outbreak, right, people have not been inoculated for that particular type of virus infection, you can have a really bad situation fast. So notice the geometric shape of this particular mastodinovirus. Do you guys know of any other examples of a polyhedral virus that you might be familiar with? Might be the reason why you're not here. What's this guy right here? This is COVID-19, commonly referred to as rose petal 19. Number 2, the binal shape. This is one of my favorite shapes of all time. It looks like a spider. Anybody else recognize there's somebody brought up the movie, what is it?
The cookie robot from Despicable Me.
Yes, yes. Very true, right? Binal virus.
Looks like the spider baby from Toy Story.
Yeah, exactly, with the baby's head on the top. That was creepy.
Megamind too.
Which one?
Megamind.
Oh yeah, I brought up Megamind. Yeah, for sure, because those guys would fly around, those little robots. Look at this. This is an electron micrograph of that very shape. You could see the ligands, the legs here. You could see the neck, right? Or the collar, as we call it. Here's the capsid. The capsid has the DNA in it, of course. In the collar, there are motor proteins. These are proteins that allow for a turning or twisting movement. And essentially, this virus lands on the surface of bacteria, drills down through the bacterial cell wall and membrane, and deposits its DNA down the chute into the bacteria and basically takes over the bacteria. This example is called a T4 bacteriophage. And this is a virus that kills bacteria. And remember, these guys are 100 times smaller than bacteria. So these guys are landing on the surface of bacteria and attacking it very quickly. It's a great shape. I like to call this the churro of the viral world. This is a helical virus. It's basically like a long cylinder, long tube that I would love to roll around in like a cinnamon sugar topping. I actually prefer the vanilla flavor myself, but they come in all different flavors. Got to go to a Sox game and pick up a churro before you. Yeah, see, you don't have that at Wrigley Field. They don't have that. What do they have at Wrigley Field? They have losing at Wrigley Field. That's what you can get for free. You walk in, you lose, you leave. You go to look at Johnny's face. What kind of look is that? You know what I'm talking about, Johnny. Cut it out. It's a complete experience on the South Side, baby. You go in, you eat, you drink, you win. You meet the love of your life. You get married. You have tiny White Sox babies. And it starts the cycle all over again. Gang, gang. Seriously, this is the class that's like all Cubs fans, right? Everybody likes the Cubs because you guys saw the Cubs win a World Series. You're bandwagoners. You guys weren't born. You were born in 2005 or 6. Yeah, 2005, right. Why aren't you Sox fans? The year you were born, the Sox won the World Series. You didn't even know that, did you? Communists. Further evidence. Know your history. 2005, baby. I went to a Cubs game that was 0-0 through all 9 innings and only ended when the enemy team scored. The enemy team. You were busy being born, yes. Lagunas just dropped out of her mom and just started rolling around the floor. Bring me birds. How are your birds doing, Jess?
They're very good. I train them to just stay in the living room so they don't fly anywhere else. They're out of their cage right now, actually.
All right, be careful. Watch where you walk. Watch where you sit down.
Yes, my brother actually almost sat on one because it was hiding in the crevice in the couch.
Exactly.
And so now he knows to look out for the birds for wherever he sits. They're very tiny. Very, very tiny.
What kind of birds are they again?
They're budgies. They're smaller than this.
Huh.
Very, very small.
Yeah, well.
Yet very, very loud.
Yes, exactly. I do remember. We all remember hearing that. Kylie even woke up. That's how loud they were. She opened her eyes. Look at her eyes. She's asleep right now. Wait, your eyes are open? Look at her squinty eyes. Rose loves birds. Anything is better than a Chihuahua, Colton. That was like Captain Obvious right there. Chihuahuas are...
They're angry for no reason.
Listen, that's an abomination right there. Who has Chihuahuas? I think Anna, you have a Chihuahua, don't you? You carry it around the house in your handbag, like Paris Hilton. Oh God, Jasmine has 4. Oh geez, that should be illegal. That should be illegal. Oh, I forgot to give you the example for this teacup Chihuahuas. Yeah, that's good stuff. Exactly. Yeah, one's blind, the other has no teeth. They live forever. Exactly. Nathan knows what I'm talking about. They're like they're like a grandparent. They just decay in front of you. Wait, that's not nice. Don't say that. Don't say that to your grandparents. Stop decaying in front of me. That's not nice. Rose would say that. That's not nice, though. Rose, don't say stuff like that. Mouse traps with legs. That's pretty good. I like that. Colton, stop being funny. All right? I like it better when I get to pick on you. All right. That's a good one, though. I like mouse traps with legs. All right. Helical virus. This is the example for this is tobacco mosaic virus, TMV. Tobacco mosaic. So tobacco plants. This is like a scourge for tobacco plants. They pick up this virus pretty easily. So that's going to destroy the crop if you don't protect against it. And then Filovirus is the last one. This looks like kind of like a rope, sometimes with a knot at one end. Filovirus shape. One very not popular, that's a wrong word to use. A very well-known virus that is filoviral shaped is Ebola. Which is also known as viral hemorrhagic fever. Within about 72 hours of contracting Ebola, it literally liquefies your tissues. And so you start spontaneously bleeding, you're hemorrhaging, you're bleeding out of your eyes, your nose, your mouth, your ears, and other openings on your body. You get the picture. And so that is nasty. Thankfully, we've never had an Ebola outbreak in North America, but there has been an Ebola outbreak as recently as last year in Africa. And so if you go to this website, cdc.gov, you could search up any pathogen and they will give you the most recent breakout. It's awesome. The amount of information that the CDC gives out is crazy. They are so up to date. All right, guys, that's the bell. I'm going to put your homework out there. It's going to be from the Pearson e-text. I'll see you guys tomorrow. Study your notes, please.